Hi, today I'm gonna give you a third lecture on deflection of beams. Before we begin, let me give you a review of previous lecture. So in previous lecture, I introduced the quadrupole integration method where we begin from the distributed loading and obtain the elastic curve. So in quadrupole integration method, after quadrupole integration, we end up having 1, 2, 3, 4 unknowns. So 4 unknown integration constant, and we have to find 4 coupled linear equations to solve for these 4 unknowns. So we discussed about how we can apply the boundary conditions to find this 1, 2, 3, 4 unknowns, and actually it was the extension of the double integration method, and there was like no further difficulty in previous lecture, and that's why we made a really short discussion about this quadrupole integration method. And then we move on to the statically indeterminate problems, where in addition to this typical beam bending problem, we have redundant support such that we have additional unknown force, and because of this unknowns, we happen to have this problem as statically indeterminate problem. For example, here we have 3 unknown reactions, 2 unknown force and 1 unknown moment. However, maximum we can have only 2 equations out of mechanical equilibrium, moment equilibrium and the force equilibrium. So because we only have 2 equations, even though we have 3 unknowns, we have to use the information about beam deflection, and the way we approach this problem was following. So in addition to this typical 2 integration constant which are unknown, we have 3 unknown forces total. We have 5 unknowns. So to find 5 equations, in addition to this mechanical equilibrium, we considered the boundary condition. Y equals 0 here, y equals 0 here, and dy dx equals to be 0 at this cantilevered beam. Of course, we have m equals 0 condition here, but m equals 0 condition is already consumed when we obtain the moment diagram, m as function of x. So this is somehow useless. So in the end, in addition to 2 mechanical equilibrium equation, we have 3 boundary conditions. Total, we have 5 boundary conditions and 5 unknowns. So we are guaranteed to solve for these 5 unknowns. However, as I told you in previous lecture, it takes so much time, and for example, if I imagine making this as a final exam, I don't want to make this problem as final exam, because I don't want to test your ability to solve for 5 unknowns out of 5 coupled linear equation. I want to test your ability to solve and formulate solid mechanics problem. So I cannot make this as final exam problem, right? So as an alternative, today what I'm gonna tell you is, instead of this typical classical way of solving the problem based on the equations and boundary conditions, I'm gonna tell you another method, which is the superposition method. Okay, if you remember, we also discussed about superposition method when we introduced statically indeterminate problems in chapter 2 and chapter 3, and you can see that this story flows in quite similar way, because this is the textbook written by the same authors, and those authors want to have same and similar flow for each chapters. Okay, so this is how the story flows in our textbook. Okay, so with this, let me wrap up the review of previous lecture.